Juan Santiago from Athena Wireless. And typically with a small cell, you have a base station, which is right here, or more base stations, and they all go back to some sort of central database. In LTE is called an EPC. It's what keeps your subscriber information, make sure that you pay the bill, and things like that. But we have some applications where they want to go and put this base station up on a plane that could lose its connection back to the internet. We put in an EPC in the spare processing capacity that we have here. So we basically now have what is called a network in a box, with just this thing, right? There's only one wire coming out, and the one wire is just getting power. That's all it's getting from here. There's no other connection to the internet. If we had an internet connection, we would plug it in right here and then surf the web and do everything else. But with our partners, we were able to put an EPC right inside this box, so instantly you get a network in a box. So let's say that you lose your backhaul connection, the connection to the outside world. You still have, what we're showing here is that we have a laptop with a movie connected to the base station, and a phone connected to the base station. So the phone is actually pulling the movie, streaming it from the laptop. Again, the types of applications that we're looking at is when you have an instant hotspot in the military, lots of applications where you have troops on the ground that want to share high bandwidth applications, video, photos, maps, those type of things between people on the ground. And if they ever lose that connection back to the home base, they can still talk to each other. The network still continues to operate and be up, and they still get all the services that they're looking for.
Well, it's similar in concept because there is a neutral host party that's responsible for the infrastructure and the equipment. But what's different is that DAS doesn't scale down to a mid-sized hotel. Let's say 200 rooms, 50,000 square feet of conference space. In that size of facility, a DAS can never be cost justified. But with small cells, you can put multiple small cell heads into the location and then provide that backhaul to the operators through the neutral host gateway. No extra spectrum, we just reuse the carrier spectrum. So the carriers are all going to have different spectrum plans for a given city. So we put small cell heads in for each of the carriers. And so there's dedicated heads for each carrier, but what's shared is the Cat5 cabling inside the building, the backhaul out of the building. All of that flows then through the neutral host gateway. And then the neutral host gateway then branches all that traffic out to the respective carriers to match up with their heads. So the carriers get what they need, which is coverage and capacity, but they also have a dedicated piece of RF gear, which they also appreciate having, or in fact require. And then the neutral host is able to do the monitoring, maintenance, management, all from a central location. And the hotel operator has a single throat to choke if they have anything that goes wrong.
So if you're trying to do a proper neutral host solution, that doesn't go far enough. You've got to implement MOCN, or some variant of that MOCN or MORAN or whatever. But yeah, from a small cell point of view, MOCN is the most convenient because it is a single carrier that then the UE or the and the macro network itself is configured to allow users, UEs, to find a carrier which might be in strange spectrum. You know, for instance, in the US here, there might be a MOCN cell on Verizon spectrum that AT&T subscribers are allowed to use. It's an opportunity for us, small cells as a service operator, service provider, which might be one of the existing spectrum owners. I mean, Jim Parker was talking about that in terms of DAS and saying, well, actually, we like to share with our with our competitors in these situations because it means we all get the benefit of he was talking about it in terms of DAS, which is a very capital intensive, so they're able to share the cost there. So a similar thing applies. You've got a not spot potentially in your network where the traffic you're serving itself doesn't justify the expense of a cell per operator. But if you have a cell which you're sharing between the operators, you can very easily justify the cost of that. And the impact is quite significant in terms of customer satisfaction in the absence of drop calls and the ability to hand off in places where you would otherwise have dropped. That's the key next step, is to say, well, how do you control and monitor it? And that's where the virtualization of the EMS comes in. because you don't necessarily want to be telling your competitors about your call drops. And so you need to be careful about what you show each of the operators from the management system. So the best way to do that is to virtualize it and say that actually the management view that one operator has over their share of the cell it looks like a cell, and they don't have any visibility of other users in the cell or even the real hardware itself. But they do have a view on their own subscribers' performance and the handovers and call drops and so on and so forth. Much extra spectrum. Well, why would you need any extra spectrum?
Octoscope were demonstrating a new compact anechoic test chambers. These microwave oven-sized boxes can support MIMO, and by connecting two together through a remotely programmable MIMO attenuator, you can simulate them moving further away from each other or closer together, ideal for handover testing.